Let's continue our discussion, and this is part 3. And today's subject is reliability program, reliability report sections examples. And we have 2 subparts. Subpart 1 is all about developing maintenance model, and subpart 2 is all about developing reliability program, reliability report. In the very beginning of subpart 1, we will try to understand connection point between business requirement one side and operation/maintenance/reliability on the other side. And I'm going to give you brief explanation about the tools that we are going to use to develop our maintenance model. And tool name is Markov chain Markov's process. Then using this tool, we are going to develop our maintenance model. Then based on this maintenance model and attributes and items that we discussed so far, we will try to group our operation/maintenance data. We will try to categorize these groups. I call it data categorization. Then, based on these groups, we will try to define reliability program summary data, summary information, and last but not least, we are going to discuss about formulas, rates, and I'm going to show you some brief examples. Quick note here, all numbers in our presentation generated using Excel random function. Now let's move to the next slide and start our today's presentation. Let's go a little bit back, and this is airline operation factorial model. We already had discussion about this model, but the reason why I brought it here, I would like to remind you that from airline operation/maintenance perspective, we have 2 major parts in this business. First part is departure oriented, and second part is fixed oriented. We are going to focus today, we are going to build our model based on departure-oriented part. Suppose this is, I put here high level, right? Let's say level 0, level 1. We are going to build the level 3, level 4 maintenance model. Now let's move to the next slide and try to understand connection points between business requirements and operational reliability. As we said, everything starts from business. Business comes and tells us, dear operation, dear maintenance, in December we are going to have 20 flights. That's what exactly I'm trying to visualize here. So green zone is flight, so we are flying, and aircraft is flying, right? And we have scheduled arrival, we landed. Then we have maintenance, after arrival check, pre-departure check, again, scheduled departure. I put here 9 o'clock as example. Then we have again flight, scheduled arrival, again 1700 example. Then we have again maintenance, then again flight, maintenance, flight, maintenance, flight. That's how we are making our money, and this is first part of the business. Second part, as we said, it is operation reliability. As a matter of fact, we already had, I think it was in the very beginning, first or second presentation, so we already had a definition of the operation reliability. It was theoretical definition. What I would like to show you now, the practical side. And from practical side, operation reliability helps us understand if scheduled departure and scheduled arrival, scheduled departure, scheduled arrival equals actual departure and actual arrival. And if not, then what happened? So, one side we have business requirements that tells us what to do, when to do, how often we have to do, even time. And on the other side, we have operation system, maintenance system, safety system, operation reliability system that supports all these requirements, that supports all these activities. And number one item in this list, number one item in these activities, it is schedule completion. And that's exactly this item, that's exactly schedule completion is connection point or bridge, whatever you like, connection point between business requirements, one side, and operation, maintenance, safety, reliability system, another side. And this is, by the way, is the first step to start developing our maintenance model. But what we need to do now, we need to define possible states for this schedule completion. And the first one, number one, definitely it is, and I think it's clear, it is availability. So aircraft is available or aircraft is not available. Second, maintenance. It can be after arrival check, pre-departure check, daily, weekly, transit, monthly, A check, B check, C check, D check, whatever you like. Next, readiness. Let me give you here a brief explanation what readiness means. Readiness means that both parties, and I'm talking here pilot and mechanic, they agree that we can do this 8-hour flight without any technical problem. As a matter of fact, mechanic signs release to service and statement says that aircraft is airworthy. So all problems fixed. Aircraft is fully serviced. We have enough fuel and etc. So that's what readiness means. Next state, take off. I think it's clear, right? When aircraft is ready, then we can take off. Next, flight. Next, we can have technical event. So I call it technical event state. We have some technical problem. The next, landing. So we have scheduled arrival, landing. Next state is maintenance. Definitely we have to do maintenance here after arrival, pre-departure. Next, if we had some technical problem, right, we need to fix this problem. And I call it fault isolation state. Next, again, readiness state. Next, take off. And next, flight. So they call it, as you can see here, call it production model cycle. This cycle repeats over and over and over again. And this is schedule completion possible state diagram. And then, as I said, we can now take this diagram and start developing our model. But what we need to do, we need to now to define the tool. And then, as I mentioned, we are going to use Markov chain, Markov's process. And let me give you here, again, brief explanation about Markov chain, Markov's process. So Markov chain, Markov's process, it has two major features. Feature number one, state can be either false or true. And number two, future depends on present, but not on the past. Now, what does it mean? Let me give you here an example. And I listed here different possible states, right? So we have major states, okay? We have scheduled departure, take off, scheduled departure, flight, technical event, we can have some technical problem, flight interruption, and scheduled arrival or landing. That's what we have here. Now, case number one or scenario number one, scheduled departure is true. So scheduled departure equals actual departure, 9 o'clock. Flight is true, we are flying. Technical event is false, we don't have any problem. Flight interruption is false. Scheduled arrival, landing is true, 17:00. Scheduled arrival, landing, 17:00. Scheduled arrival equals actual arrival. Now, scenario number two or case number two. Scheduled departure, takeoff is true, 9 o'clock. So scheduled departure again equals actual departure. Flight is true, we are flying. Technical event is true. Let's say we have some engine problem. Flight interruption is true, and I'm using here, just bringing all these flight interruptions, we already had discussion. But I'm using for better understanding, diversion. Let's say we diverted, this is airport E, right? And scheduled arrival or landing is false. I'm talking here about from time perspective, 1700. As a matter of fact, not only scheduled arrival is false, but if we could add here, we can, by the way, continue this list, right? Whatever we want, we can add here. Also, destination airport is false. We can add here destination airport, right? Let's say this is B, our destination airport, but we have diversion. And now we landed in airport E, emergency airport. And this is all in spite of our scheduled departure. Scheduled departure is true, 9 o'clock. Scheduled departure here equals actual departure. But unfortunately, due to this technical problem, the scheduled arrival not equals actual arrival. Excuse me, here. The third interesting feature for Markov chain, Markov's process, is also we can calculate transition probabilities between these states. Definitely, we are not going now this calculation here. Now, what I'm going to do, let's go back to our presentation and using or starting from this schedule completion possible state diagram, start developing our maintenance model.